So how do you actually take a reading? So I have my carbon dioxide probe, and it's been giving me some readings that kind of continue to increase. And so I want to know, what value do I actually record for the value of carbon dioxide? And so there's a couple ways to do this. A simple way that's a little less accurate is to just wait for it to kind of normalize and say, okay, well, I waited and it's not really increasing much more at this point. And so I'm going to say that my value of parts per million is around, let's say, 1222. And that's because it doesn't seem like it's increasing more than that. So let's say that our value is 1222. And you've waited 90 seconds to let it normalize, plus waited an extra about 60 seconds waiting for it to kind of stop increasing. So that's one way to do it. That's a little bit less accurate to just wait and make a judgment call. A little bit more accurate would be to wait the 90 seconds, then start a run, which is what it's called on the interface. So to do that, you'll notice that on this screen, it's basically just telling you what the gas sensor is actually reading. So you can ask it to record what the gas sensor is reading. So to do that, you have a little button down here that looks like a play button, and that would record. Now the default settings tell it to record in a certain way. So if you see on the right here, it says time. And it's going by every 4 seconds. And if you look down here, it also says that it's going to stop at 600 seconds, and it's kind of making a little graph for you. So it's going every 4 seconds for 600 seconds, it's recording a value. And then eventually it'll stop on its own at 600, but I'm going to stop it myself to show you another way to carry that out. So let's delete or just start a new run. So I pressed this button to start a brand new run. If we go back to the main screen by hitting the left top corner, take us back to the main screen, and we click right here, it'll allow us to change those intervals to make it whatever we want. So for example, instead of having it do every 4 seconds for a sample, I could do, I don't know, let's change that. And I'll need this little keyboard. And I'll delete that. Let's make it every 10 seconds. And I'll hit OK. And I'll change one other thing, and that is how long I want it to record. Because I don't need 600 seconds, that's like 10 minutes of recording. Instead, I'll just make it 1 minute, and I'll hit OK. So if I've made it so that it takes 10 samples, or rather one measurement every 10 seconds, and I've let it run for 60 seconds, it's going to take a total of 6 samples. So now when I press play, I can just let it run, and it'll run for 60 seconds, as it says right here, 60 seconds, and it'll go every 10 seconds, it'll give me the measurement. This is really accurate because this will allow me to kind of come up with a true value instead of just eyeballing it, give me a true value for where the CO2 parts per million, the concentration, is kind of normalizing. So while we wait for this graph to be made, where can you actually find the data points? Well, there's a little X and Y symbol right here. And it's actually recording, so we're on run 2, so we'll look there. Ooh, it'll allow me to name it, but I don't really want to do that. And you see here the parts per million that it's recording for run 2 every 10 seconds. So I can average these, but guess what? I don't even really need to average it because it looks like most of them are around 1225. But a really strong way to measure this would be to just average all of these. So every 10 seconds, it's giving us about 1222 to 1225. So this is a lot more accurate, and I highly encourage it. And that would be your initial value. So your initial reading for carbon dioxide. And then when you want to do the final, you just do the same thing again, just run it in the exact same way and get an average.